In order to get a little better feel for what base 10 numbers really mean, and it's difficult to teach this because you've used these numbers your whole life, it's so instinctive to you that you might not appreciate it. You might not be able to look at it from the outside. Incidentally, I always tell future teachers that the people who struggle the most in school tend to make the best teachers because they can sympathize with students who are not understanding it. People for whom things are very, very easy don't make very good teachers. They stand up at the front of the board and they say, "Look, it's a piece of cake to me," and the rest of the class is like, "Well, it's not for us." In any case, base 10, I want you to have a better understanding of it. So let's talk about base 8 for a little bit. What would it look like if we based our numbering system around a number other than 10? Why do we use 10? Probably because we have 10 fingers. But what would happen if we used base 8? Then it's a positional system again. There's different places, and where a number is makes a big difference. But we still have the ones place. And now, instead of each place being multiplied by 10 to go up, we go by 8. So you have the eighths place. You multiply that 1 by 8, and you get eights. Times 8. And if you multiply again, times 8, you're going to get 8 times 8, or the 64's place. And if you multiply again, you get the, oh lordy, 250, nope, 512's place. 8 times 8 times 8 is 512's place. And if you multiply by 8 again, we're going to get 4096's. And again, every time you take a step to the left, you're multiplying by 8. Every time you take a step to the right, you are dividing by 8. Which means that you even have fractions. You divide by 8 and you get the 1/8ths place. And you divide by 8 again and you get the 1/64ths place. So what does this mean? This means that when you see a number in base 8, each digit represents some number of eighths. If your number is 3, 4, 7, then what does this mean? This means we have 3 times 64 plus 4 times 8 plus 7. That first digit, 3 times 64, is 12, and 180 is 192, plus 32 plus 7 is 4, 11, 10, 13, 231? 4, 11, 13, I believe so. Now, how can we write 347 equals 231? That's ridiculous. No, the first number is being represented in base 8, and the second number is in our traditional base 10. So what you do is you put a little 8 down there and a little 10 down there, indicating that these numbers are being written in a different way. Let's do a couple more examples of this. If our number had been 2406. Now notice, we can't use digits above 7. We use the base 10 numbering system. The highest digit we have is 9 in base 10. In base 8, the highest digit is 7. If you want to write an 8, if you wanted to write in just an 8, it would look like this. 1, 8, and no ones. So what was the last one? 2406. This is 2 512s plus 4 64s plus 0 8s plus 6. And that is 1024 plus 128 plus 6. And that's 1018, carry the 1, 3, 5, nothing carries, the hundreds is 1, and 1. So then we would say 2406 in base 8 is 1158 in base 10. Now let's try going the other direction. Now let's say we have a number in base 10 and we want to represent it in base 8. Let's say we have the number 528, let's say, and that is in base 10, and we want to represent it in base 8. That means to say we want to put it in a positional system where we have the 1's place, and then the 8's place, and then the 64's place, and then whatever the 64 times 8 is, I keep forgetting that, 480 plus 32 is 512. And the next one is going to be, what was it, the 96 places. Now, what we have to do is we have to have 528 represent some number of 4096s, some number of 512s, some number of 64s, some number of 8s, and some number of 1s. Well, here's the trick. Start from the largest amount. How many 4096s are in 528? None. You can put a 0 there or you can skip it. But we can fit some 512s in there. We can take one 512 out, and we're going to be left with 528 minus 512 is 16. 16. How many 60? So we have this one here represents 512. It's in the 512's place. If we have only 16 left, we can't get any 64s. There's none. How many 8s? Exactly 2. 2 8s use up another 16. There's nothing left. And therefore we say 528 in base 10 is 1020 in base 8. Let's try another example like this. Let's say we want to turn 793 from base 10 into something in base 6. Well, base 6, we haven't even talked about base 6 yet, but it's got positions. It's got the 1's place, and then it's got the 6's place. And then we multiply that by 6. 6 times 6 is 36. The next place is 6 times 6 times 6, which is 216. That comes up from time to time in mathematics. We are going to have room for 216s if we multiply that by 6 again. I'm going to have to get out my calculator. And what does it say? 216 times another 6 is 1296. Well, that's too big. We don't have any 1296s in our number. We do have some 16s. Here's the trick. How many 216s are in 793? 793 divided by 216 is 3 and change. That means that there are 3 216s in 793 with something left over. What is 3 times 216? 3 times 216 is 648. So we have our 793. What was that number again? 648. Minus 648 is 584. And we didn't carry, so 145. So this 3 right here represents 3 216s, which is 648. We have 145 left. Hey, can we find any 36s on 145? You bet. We take 145 and divide it by 36, and we see 4 and change. There's 4 in there. What is 4 times 36 is 144. Even better, 144. So that uses up all but one of them. Minus 144 gives us 1 left over. There's no 6s in that. 1, 1. And so what we're saying is 793 in base 10 is 3401 in base 6. And if you want to verify that, all you have to do is see that to verify, all you have to do is say 3 times 216 plus 4 times 36 plus 1 had better come out to be 793.